Imagine waking up tomorrow and gravity no longer works. Cars would float, buildings would crumble, the oceans would slowly drift away from Earth. Even the air you breathe would escape into space. Within minutes, life on Earth would become impossible. That one invincible force controls almost everything around you. But here's the crazy part. Gravity is only one tiny chapter in the story of physics. Physics explains why stars shine, why magnets stick to your fridge, why airplanes can stay in the sky, why your phones can connect to satellites, why time slows down near black holes, and even why the universe exists the way it does. So in the next few minutes, let's explain all of physics. Chapter 1. What is physics? Physics is the study of the rules that govern reality. Every falling apple, every lightning strike, every moving planet, every crashing wave, every atom inside your body. Physics asks one simple question: what rule makes this happen? For thousands of years, humans blame unexplained events on magic or the supernatural. Then scientists began observing, experimenting, and measuring. Instead of guessing, they tested ideas. Over time, they discovered that nature follows predictable laws. The same force that makes a pen fall from your desk keeps the moon orbiting Earth. The same electricity that powers your light bulb also exists inside your nervous system. Physics connects the tiny world of atoms with the enormous scale of galaxies, and surprisingly, almost everything can be explained using just a handful of fundamental principles. Let's begin with motion. Chapter 2. Motion and Newton's laws. Imagine kicking a ball. It rolls across the field. Eventually, it stops. Many people think motion naturally fades away. Wrong. The ball stops because friction between the ball and the ground slows it down. If there were no friction, it would keep rolling. Sir Isaac Newton realized this more than 300 years ago. He called it the first law of motion. An object stays at rest or keeps moving in a straight line unless acted upon by an outside force. His second law is even more famous. Force equals mass times acceleration. F equals ma. If you push a shopping trolley, it moves. Fill it with heavy bags, and suddenly it becomes much harder to accelerate. The more the mass something has, the more force you need. Then comes Newton's third law. For every action, there is an equal and opposite reaction. When you jump off the ground, your legs push Earth downward. At exactly the same time, Earth pushes you upward. Rocket launchers work the same way. Hot gases blast downward. The rocket shoots upward. Newton's three laws of motion explains the movement of planets, trains, bicycles, falling apples, and even your own footsteps. Chapter 3. Energy. Energy is the ability to do work. Everything that happens requires energy. The amazing part is this: energy can never be created from nothing, and it can never completely disappear. It only changes form. When you eat breakfast, your body converts chemical energy into movement. When a roller coaster climbs a hill, it stores gravitational potential energy. As it drops, that stored energy becomes kinetic energy. When you rub your hands together, movement creates heat. When lightning strikes, electrical energy becomes light, sound, and thermal energy. Even the sun works because nuclear energy inside its core transforms into heat and light. The universe is constantly recycling energy. Nothing is truly lost. It simply changes shape. Chapter 4. Electricity and Magnetism. Modern civilization depends on electricity. Your phone, your laptop, traffic lights, hospitals, airports, everything. Electricity is simply the movement of tiny charged particles called electrons. When electrons flow through a wire, they create electric current. But scientists discover something remarkable. Moving electricity creates magnetic fields. Changing magnetic fields can also create electricity. This relationship is called electromagnetism. Generators inside power stations spin giant magnets to produce electricity. Electric motors reverse the process by using electricity to create motion. Without electromagnetism, there would be no internet, no television, No MRI machines and no smartphones. The digital age exists because of one of physics' greatest discoveries. Chapter 5: Waves and Light. Not everything travels by moving objects. Some things travels as waves. Sound is one example. When you speak, vibrations move through the air until they reach another person's ear. Light behaves differently. Light is an electromagnetic wave. Unlike sound, it doesn't need air or water. It can travel through the empty vacuum of space. That's why sunlight reaches Earth after crossing 150 kilometers of emptiness. The colors you see every day are also fascinating. Objects don't actually contain color. Instead, they absorb certain wavelengths of light and reflect others. A banana reflects yellow wavelengths while absorbing most others. Your eyes detect those reflected waves. Your brain turns them into the color yellow. Color exists because of both physics and perception. Chapter 6: Atoms and Quantum Physics. Everything around you is built from atoms. Your body, your clothes, your chair, the water you drink, even distant stars. Atoms contain a tiny nucleus made of protons and neutrons. Electrons surround that nucleus. For a long time, scientists believed atoms were the smallest possible objects. Then they discovered even smaller particles, and reality became strange. At the quantum level, particles sometimes behave like waves. Some don't have one exact location until measured. Instead, they exist as probabilities. This sounds unbelievable, yet experiments repeatedly confirm it. Quantum physics explains laser, semiconductors, modern computers, solar panels, and quantum computing research. Without understanding atoms, modern technology would not exist. Chapter 7: Einstein and Relativity. Albert Einstein transformed physics forever. He proposed that space and time are connected. Together they form something called space-time. Imagine placing a heavy bowling ball on a stretched sheet. The sheet bends. Now place a marble nearby. It rolls towards the bowling ball. That's similar to how gravity works. Mass bends space-time. Planets follow those curves. The larger the object, the deeper the bend. Einstein also discovered something astonishing. Time itself is flexible. It moves more slowly near massive objects and at extremely high speeds. Astronauts in orbit experience tiny differences in time compared with people on Earth. GPS satellite must constantly correct for these effects. Without Einstein equations, your navigation apps would become inaccurate surprisingly quickly. Chapter 8: The Universe from the Scientific Point of View. Everything scientists currently know suggests that the universe began at about 13.8 billion years ago in an event known as the Big Bang. Space itself rapidly expanded, matter formed, stars ignited, galaxies assembled, planets appeared. Eventually, life emerged on one small rocky planet orbiting an ordinary star. But despite centuries of scientific progress, enormous mysteries remain. Scientists estimate that ordinary matter accounts for only about 5% of the universe. The rest appears to consist of invisible dark matter and mysterious dark energy. We know they influence galaxies and cosmos expansion. We still don't know exactly what they are, which means most of reality remains unexplained. But we do know for a fact that there is a supernatural force. Conclusion: physics is not just a school subject, it is the language of the universe. It explains falling apples and exploding stars, tiny atoms and giant galaxies, electricity and black holes, rainbows and rockets. Every answer physics provides leads to another fascinating question. So the next time you drop your phone, watch a sunset, hear a thunder, or gaze at the stars, remember this: you are not just observing the world, you are witnessing the laws of physics in action.